Everyone. I hope you can see and hear me well. Davide, I trust that you let me know if anything doesn't work out. Today in a rather unusual scenario, actually. Please forgive me, I'm a bit rusty in presenting like in this live form, but as it is again the beginning of the year and we are hopeful that this will finally be the year where we will return to conferences in person, I thought this would be a good opportunity to try to present this way again. So I'm going to give you a quick status update of my PhD. Actually, I haven't done one in 2021 because somehow I did one in the end of 2020, and now this one is sort of the second one I'm giving. And for this, as a brief overview, I would like to mention three main parts. First one, looking into the past, sort of what we've been or what I've been working on. Now, this is probably rather unusual because the more interesting part is what's about to come, also where I would like your feedback on. However, I have the feeling that PhD seminars or presentations like this are always in the sense of, yeah, this is what we'd like to do, this is what we want to do. Also, everything is always very preliminary. And with this, I at least briefly want to show you that we've actually done something that works and which we are quite proud of. So I would like to take at least a few minutes to show you what we've done there. Of course, the more interesting part for you probably then is what I'm doing right now, and finally what I want to be doing in the future. I want to keep this presentation on a fairly high level, actually, so I'm not going to go too much into research methods. I'm fairly confident that I'm relatively settled there, but the overall direction is what I want to present you, and maybe where I want to collect your ideas and your propositions that I could use for orienting myself for the coming 3 years, because it's only 3 more years from here suddenly. Okay, so let's talk about sort of the past. Our project Causality and Requirements Artifact, short KIRA, is what I would briefly like to demonstrate to you what we've done there in the past year or year and a half. Actually, this was a collaboration together with Yannick Fischbach, a PhD student from Germany. Some of you have met him, especially those who were here, as he was a visiting researcher actually. And this was also the time where we finalized that work. To briefly catch you up on what the main idea or what our research roadmap was, we wanted to understand how causality was used in requirements artifacts and requirements engineering in general. We published a few papers on this. First of all, understanding whether causality is actually used in requirements artifacts, then how these are interpreted, whether they are interpreted ambiguously or not. And then our sort of magnus opus, our final work, which is on the in the right section of this box in the middle, is we were trying to use automatic causality extraction in order to generate test cases from conditional requirement statements. And how this works is something that we would like, or I would like to show you briefly, because it actually works surprisingly well for some cases. We're also looking into continuing this, as there is quite some interest from companies in using that, actually applying that, but that is sort of music of the future. Now, what did we do in our latest paper? The idea was to take a natural language requirement as an input. First of all, classify it on whether it is causal or not, whether it contains a causal relation or not. This was the work we've done, I think it was early last year, where we built basically a binary classifier that is capable of detecting whether a sentence contains a causal statement or not. Then we are labeling the parts of the sentence which belong to the different events that happen in the sentence. We're constructing a graph from that, and from this graph, it's possible to derive the minimal set of test cases that you would need in order to assert that this statement or this requirement is met in the end. A very simple example, if you take a sentence like this, I know it's a bit small, but I hope the people, at least on the screen, can read it. But a very simple causal sentence like, when the red button is pushed, or the power fails, the interface does not accept further inputs, and the system shuts down. Here you can already see this is not just an if-then statement. It has some more events and some negations that happen here. So what we did in our main work, or what was the bulk of our main work, was to build a labeler. So this is what our labeler is capable of. First of all, identifying the events in this sentence, so identifying what are causes and what are effects in this sentence, but also identifying what are the combinatorics between them. So are these sentences conjuncted, are they disjuncted? And in each event, what is the variable and what is the condition? So for example, for the first cause, the variable being the red button, this is the object, and is pushed is the condition under which the object has to be in order for this causal relationship to happen. This can then be translated into a cause-effect graph, looking like something like this. And a cause-effect graph, there's already enough literature about this, can be translated into a test case by using all of the combinations that are necessary to uniquely test sort of all variations that there are of this cause-effect graph. Now, this example is already quite illustrative, but the cool thing is that you can actually use it. We've built an online demo you could use yourself. So if you access this link, you can find our online tool where you can basically go through all of these steps yourself. It's very nice. It has nice colors and works most of the time. If you manage to break it, please let us know. We're always interested in the corner cases. But this is basically what we've come up with so far. And now we're trying to apply this also in practice and see how this type of automatic test case generation can be used in order to accelerate the testing process in practice. Good. So far to this is what has been, but now let's come to the present, and with this also to my main topic of my thesis, of my PhD. Good enough requirements engineering is the keyword basically I'm dealing with, and this is a difficult to interpret keyword because what is good enough? But this question of what is good enough starts with what is good in the first place. So what are good requirements? What is good requirements quality? And this question, or trying to answer this question, at least working towards an answer of this question in a systematical manner, that is my goal for my PhD. The first and very natural thing to approach when talking about good enough requirements engineering or requirements quality in general are so-called quality factors. So a quality factor, it has different names in literature. Sadly, there is no sort of unique terminology, but we're working on that, and that's something I'll come to. But we'll use the term quality factors right now. A quality factor is something we define as a normative metric which maps a textual requirement. So we're limiting ourselves to text of a specific granularity to a scale which informs about the quality of this input. Sounds very complicated, but it isn't. Actually, it's one of the most common usages of trying to sort of identify or detect quality or violations against quality and requirements artifacts. And it's actually very easy to apply. If you sort of formalize it into something like this, it's basically a function that maps some sort of textual input to a scale. And one very easy example of this would be, for example, the use of passive voice. Anyone who has dealt with requirements quality has probably heard you shouldn't write a requirement sentence in passive voice. And this statement, this prescription already is sort of a formulate, or you can reformulate that into a quality factor, which would mean the occurrence of passive voice in a requirement sentence is associated with bad quality. You can see here that the different parts of this quality factor can take different types. For example, the input type, so the textual input of a specific granularity. It could be a sentence, it could be maybe a whole section. For example, if you want to detect cohesion within a section of a document, or maybe it could even be the global scope, which could be all of your requirements. For example, if you're trying to detect something like textual redundancy, for that you would need to see the whole document, basically the global sphere of all requirements artifacts that you have. And also one thing you would notice here is that the scale to which this quality factor maps is pretty simplistic right now. And this is the most common thing. You see a binary scale, sort of a good and bad scale, which is derived from these prescriptions that say do something like this would be bad, or doing something like that would be good, or avoiding something like that would be good. Passive voice is something like that. Or another quality factor you could easily think of is text length, which is also quite commonly used to evaluate the quality of requirement statements, because we associate very long sentences with an impairment to readability, to understandability, and in general, we assume that the complexity increases the longer a sentence becomes. However, those are assumptions, and that is something we need to talk about, because there is a lot of problems of these quality factors. You've probably heard of some of these quality factors. One very prominent suite of quality factors, for example, are the requirement smells proposed by Henning Femmer, which are very popular and easy to apply. However, it always raises the question of the relevance of these quality factors. So do they actually represent a defect in requirements quality? And also these papers that propose quality factors are having a hard time actually connecting their results, their metrics, to actual quality, because the use of passive voice does not necessarily lead to a bad requirement. It might be that it doesn't have any impediment to requirements quality at all. So what we need here is, from my perspective, a holistic and especially systematic perspective on these quality factors. And that is what we're trying to contribute with our current work. We are working on a quality factor taxonomy, at least we're working towards it, where we are contributing basically two things. On the one hand, we want to provide sort of a structure which harmonizes the terminology around quality factors, but also defines sort of the ecosystem around quality factors that exist in general. So what you can see on the left side of the presentation is sort of the structure we've derived right now. We actually came to a conclusion that we need more than one taxonomy in order to fit all of the things we want to relate with each other. So it's more it goes into the direction of a ontology or even content map, because every quality attribute or each quality attribute can be associated to multiple different descriptions, because that is also one problem, because there is no such thing like a central repository of all quality factors. You see that a lot of papers propose redundant quality factors, and sometimes they even use conflicting or inconsistent descriptions for that. So a quality attribute, as it was called in previous iterations, but quality factors, what we mean by this, can also be associated to multiple descriptions. And then for each of these descriptions, there might already be data sets that have these defects or violations against the quality attribute annotated, which would be an excellent starting point for new research to improve upon the detection algorithms, for example. And detection algorithms is the next keyword. Approaches, as we call them. There are already quite a lot of implementations to detect, for example, sentences containing passive voice or sentences containing vague adjectives. That's also one very common quality factor. However, there is no way of sort of finding what has already been done. There is no way of a central access to maintain, to reuse, and to evolve these quality factors, which basically leads to the fact that this quality requirements quality community somehow sort of keeps stepping on its own toes and doesn't really go beyond this spot. And that's why we are creating this quality factor taxonomy. The four meta characteristics you see on the right side are basically the requirements for our taxonomy. What we wanted to provide is, first of all, that you're capable of understanding what this all means. So basically that you have this one place where you can centrally find all of the requirements, quality factors that have already been proposed in literature, but also that you can apply and reuse what has already been done. There is no necessity to develop the fifth algorithm that detects passive voice, because there is already enough algorithms that do that. However, it's difficult to find these, and we are trying to connect our data sets where we can say, if you're interested in a specific quality factor, we can show you all of the approaches that have already been implemented for something. And the other meta characteristics basically go into the same direction. We want to have this maintainable, this evolving quality factor taxonomy that helps us sort of give us a baseline, give us a benchmark of what we already have in research. The question that comes up here, and what I've been teasing on before, is now, do they really matter? So all of these quality factors, as I've said, our normative rules, they proclaim the use of passive voice leads to, well, having bad requirements. But is that actually the case? This, I would say, is a very natural question. We should always question whether the things we do actually achieve the goals that we are trying to achieve. However, you see that in literature, this question is asked very rarely. So there's very rarely a connection being made between these normative rules and actual quality. But what is actual quality? And this is where we come to a, right now I'm framing it as the requirements quality theory, where we're trying to bring together all of the concepts surrounding requirements quality and how they influence each other. Our requirements quality factors are basically the most simple types that you can think of. Passive voice, sentence length, things like that, easily detectable on the requirements themselves. However, what actually matters are what we now call requirements quality aspects. And those are things that are sort of aspects of quality that are only measurable in the interaction of a human with a requirement. Requirements are, as we often state, a means to an end. Requirements are meant to be read by someone, to be used, to be processed, to be translated into architecture, to be translated into code, and to be translated into test cases. The requirement itself is not a deliverable. It is a means to an end that needs to fulfill its purpose. It needs to be fit for its purpose. And this purpose is, for example, being interpreted and then translated. And only if these activities of reading and translating requirements are impeded, only then we can actually say this quality or this requirement is of bad quality. Because if we're using, for example, passive voice in our sentences, but let's say under a given context factor of a very small team size, let's say you are working with only a team size of 2 or 1 person. Well, if the people know each other so well that they, by whatever reason, they already know who is meant with these passive statements, well, then there might not even be a need to change these sentences into active voice. It would be wasted effort to force someone to rewrite passive statements into active voice if it doesn't really matter, if it doesn't really influence activities. And that is why this relation is so important to be considered, that requirements quality factors only are relevant if they have an impact on requirements quality aspects. And this is one of the most, this is a very intricate relationship. However, this is nothing new. Henning Femmer already proposed this with his activity-based quality models. However, this is not reflected in literature. So barely anyone who proposes a new requirements quality factors tries to also look into whether this factor actually influences any activities, whether it influences and therefore requirements quality aspects. And this is a huge gap in research I want to tackle in my PhD. Finally, there's even a point to be made that even the occurrence of, for example, ambiguity, inconsistency, incompleteness, something like that, does not necessarily lead to any consequences. It might be that due to the extreme diligence of your team, the extreme diligence of your developers or testers, that they can make up for these problems like ambiguities or incompletenesses. So it doesn't necessarily need to, for example, decrease business value or something like that. The cool thing about this relationship, if we just theoretically think we could sort of complete this relationship from the beginning to the end, would be that it would be possible to estimate how the occurrence of a quality factor basically influences in the end your business value. And that would make very specific sort of what impact quality defects and requirements have on your project. And I think this is sort of one of the key relationships that are, it's questionable whether we can ever properly map them. But if we could map them, we could make very clear to companies how defects in requirements quality propagate to defects in actual business value. So this is probably more of a sort of a grand vision and probably something that will never be achieved, but at least to keep this in mind is very important. Now, the final part that I want to talk about is sort of where is my research located? And that starts with the question, these requirements quality factors, are they not irrelevant even if we think about this, that quality aspects are the actual sort of consequences on requirements quality? I would claim no. because still requirements quality factors have the huge benefit that they are very easy to apply, and especially a lot of them are automatically applicable. So for a lot of them, like detection of passive voice, of sentence length, something like that, is very easy to automate. So you can apply these kind of quality checks very early and very cheaply. You can even have like a background job doing this on any new requirement that comes in. The key here is that requirements quality factors only gain relevance if we are capable of understanding the relationship between these quality factors, context factors, and the quality aspects. And that will be sort of the main point of interest of my thesis, and probably will take the longest time. So how does this look like? Where am I locating my research? First of all, we're working on this taxonomy for quality factors. This is what we're eliciting right now. This is basically a taxonomy elicitation process and a tool building process that we're involved with right now. And the other thing, that's exactly what I've been telling now about this theory, this conceptual model. This is more of this is hypothesized to be a position paper on requirements quality research in general. The question now is where to go from there. I have a few ideas which I am going to propose, but I would also be very interested to hear your perspective of what you would recommend doing or what would be interesting. A first thing, of course, would be to understand the quality aspects also of requirements. So one of the reasons I think for many of the papers in literature neglecting to connect quality factors to quality aspects is that evaluating quality aspects is a lot harder than it is to evaluate quality factors, because quality factors you can evaluate, for example, an automatic detection approach with some simple precision and recall value, trying to see how many of the annotated instances in a data set does your approach find. But how do you measure an impact, for example, on ambiguity? And these kind of measurements are that complicated because they involve human interactions, because quality aspects are only measurable on activities that involve human people, human stakeholders. So probably an interesting work would be to understand what kind of measurements do we have to, for example, measure ambiguity or measure understandability, readability, things like that. Of course, a very interesting work, but probably a very challenging work, would be to connect these two. So can we, for a specific set of requirements quality factors and a specific set of context factors, understand how they influence these quality aspects? So can we, for example, for certain scenarios, say how likely the use of passive voice is to introduce ambiguity? If we have the measurements on both sides, there might be some sort of experiment set up possible to test this, but this would be probably quite challenging. And in the end, well, this would be probably the most interesting from a business perspective. Could we even investigate this relationship of how ambiguity, for example, relates to loss of business value? So something like that, but that's probably a wishful thinking. However, I'd like to hear your thoughts on that in the end. Coming to a conclusion, just a brief overview, if any of you are interested to see sort of what I'm doing with, but so far I'm relatively well in my plan regarding publications and courses. So I'm expecting to finish my courses by the end of next year, and while my publications are on the way, we still need to convince some reviewers in a second round, for example, for our Kira paper, which has sadly been rejected from ICSI, but we're working on it and are still confident that this will work out. So this is basically how it looks like. And now I would be very interested to hear your thoughts, or if you have questions for me, then please go ahead and ask.